Let's take a look at the kinematic equations again, except this time we're going to use some numbers to show you how to plug them into our table. We have a similar situation where you have a car that's moving at 20 meters per second, and it's going to come to a complete stop. But this time, you know how long it has to stop in terms of distance. It's going to stop in a distance of 100 meters. So what this problem is going to ask is, what is the deceleration of the car if it can stop in 100 meters? Assuming it started at a speed of 20 meters per second. So the first thing we need to do is come over to our table and fill it out. So let's go through our conditions. I'm going to choose this is 0, and I'm going to choose this value as the 100 meters, that is. Always write your units. So our initial position is 0. Our final position is 100 meters. Our initial velocity is 20 meters per second. Our final velocity is 0 because we said that the object came to a stop. And we don't know what our acceleration is, and we don't know what our time is. Okay, so let's go through the steps. The first thing we need to do is find out which equation we need. So ask the first fundamental question. Which equation has what I need? Well, we need acceleration. All three equations have acceleration, so we still have the same three equations to work with. But now we ask the second question. Which equation, the second question being, do I have what the equation needs to give me the right answer? Well, the first and the last equations need time. And if we look on our table, we don't have time. So you've now eliminated your two equations, and you're back to equation in the middle, equation 2. So v squared equals v naught squared plus 2a delta x. So since we're solving for the acceleration, let's algebraically solve. So we'll bring the initial velocity over. And then we'll divide both sides by 2 delta x. And we're left with, whoops. Now you're ready to plug in your numbers. What numbers do you plug in? Just go over to your table. You have your initial velocity, your final velocity, and you have your values for delta x, because if you recall, delta x is equal to x final minus x initial, which you have. So a little note about acceleration. Since the car was slowing down, we know that the acceleration is going to be negative. So you can say it's a negative acceleration, or sometimes you could use the phrase it's decelerating. But I wanted to make sure you understood why it's negative. You can say, one, it's negative because the object's slowing down. But mathematically, what's going on? So if you define acceleration as the change in velocity with respect to time, then that's the same as saying v final minus v initial over t final minus t initial. Well, if your initial velocity, which is the object moving, is larger than your final velocity, which is 0, then as you can see, this number that you're going to get is going to be a negative v initial over some time. Therefore, your acceleration is negative. So though I didn't put it in here initially, understand that the sign of this acceleration will actually turn out to be negative and this positive because of the fact that the car is experiencing a deceleration. So plug in the numbers and see about the answer you get. If you have any questions, just run the videotape back and see if you can figure it out. Or leave a comment in the section and I'll see if I can get back to you very quickly and answer your question.